Okay, this is an angle of elevation problem, and this is one of the times that I get to show my artistic ability. Well, the few times I get to show it simply because after I show it, everybody screams, yells, holler, and I can't ever show it again because it's so good. Everybody just, is in such high demand. Yeah, right. Okay, anyway, I hope you can tell sort of what's going on, but let's describe this problem for you. We have an airport and a runway, and we don't see the airport, but we do see the runway. It's right here. And here's the end of the runway, okay, end of runway. And at the end of that runway, there starts a mountain or a mountain range, okay. And from the end of the runway, 6,700 feet from the end of the runway, there is a peak. And that peak rises. It is 1,550 feet above the level of the runway. Now, that's not the height of the peak. That's how high it is above the runway at its highest. Now, we'd like very much to clear that thing. We'd like very much for this airplane, as it's taking off right here and going up, we would love for it to clear that thing at by 200 feet, at least. It'd be nice if it was more like 1,000, 500, but it's got to clear it by that in order for us to have safety, okay? 200 feet there, all right? Because you've got wind and whatever else. As you can see, there's other things in here, so on and so on. So we really would like for this thing to have an incline such that it makes that, okay? Well, what we'd like to know is what is the angle of ascent? Ascent meaning going up. So what's the angle of elevation, angle of ascent that that airplane has to take, okay? Go up so it can clear that. We want that angle to be the same. We don't want the pilot to change. Once he sets it, we want it to go up. So what is this angle right here? That's what we want to find out. Right here, this angle. What is the measure of this angle? What is the angle of ascent? Okay, that's what we want to know. Okay, so let's look at this and see what we can figure out from it and go from there. What we've got is, we've got an ascent. If we're standing, we're going to be standing right here, okay, on this problem. Our position is right here. We're looking up. It's an angle of elevation problem. We have one side, which is what? No, I've got to put my SOHCAHTOA over here. Otherwise, I don't know how to do this. We have one side, one leg over here that is 6,700 feet. We have another leg that has two pieces, 1,550 feet and 200. So what's the total of this leg over here? Well, this total of this leg over here is 1,750 feet. Okay? And we've got this. So what has the two legs? So, ka, or toa? Well, the so and ka have to have the hypotenuse. Do we have the hypotenuse? No. The hypotenuse is opposite the 90-degree angle. The 90-degree angle is here. It's there. So we're looking at, can't use these two because they have to have hypotenuse. We're looking at toa, which is tangent. So what we're looking for is looking for the tangent of our angle equals what? Opposite over adjacent. Well, the total opposite height that we want is 1,750 divided by what? 6,700. Now, do we know the angle? No. We don't know the angle. So can we use the tangent function? No. We have to use the what? We have to use the inverse function. So we're actually going to have tangent inverse 1750 divided by 6,700 equals our angle of ascent. Okay? So let's get our calculator out and let's do that. this right here, how do you do the inverse function? Second tangent. Put this in there, this number divided by this number, close paren, press enter. Let's see what we get. Okay, I come up with this angle right here. This angle right here has to be greater than 14.64 degrees. It's got to be bigger than that. Okay? Whoops. It's got to be bigger than that. Angle A has to be bigger than that. Okay? So as soon as he takes off, boom, he has got to have that thing at about 15 degrees. Okay? 14.7, 15 degrees in order to make this safety. Okay? Angle of elevation. Angle of elevation problem. That's what an angle of elevation problem looks like. Okay, do you have to be this fancy on your drawings? No. Draw it's very simple if you want to. I just like to ham it up.